Oh.
How was everyone's day?
Good.
Good.
Did everyone catch devotional?
No.
Good. Holy
That
smokes.
was good.
So good.
Mhm.
I was bawling.
Yeah, it's really good.
Who did the devotional?
Stephanie Nielsen, right? That's her name?
Uh-huh.
Yeah, she's. Are you familiar? She was in a plane accident in 2008, and
Yeah,
she's
I
a
dated her.
blogger. Yeah,
Yeah,
she's
she's.
super. What?
Mormon message.
I've met her a few times. Well, good. I'm glad you guys had fun in devotional.
Oh, yeah.
So much fun. Did you guys look over our assignment, our quiz?
No, I literally just got home.
Well, shoot. My understanding is it's just like a overview of what we've learned so far, so I don't think it'll be too hard, but
Okay.
so should we just go right into it?
Yeah.
Let's go for it.
Okay, well, there's 31 questions in this quiz. Take a
Okay, is everybody there yet?
Mine's
Yes.
loading really slow.
It's gonna be so much fun. So excited. All right, is everyone there?
Yes.
Teddy. All right, I had to change my shirt because it's a little hot in here.
Okay. I can read the first one.
Okay.
Which of the following variables is/are categorical? The number of animals at the local zoo, a randomly selected branded toothpaste at a convenience store, age and years of randomly selected vehicles in a parking lot. Toothpaste?
I think we can pick more than one, can't we? If we need to.
Oh, yeah, we can.
And I think also age of randomly selected vehicles. Because that's a number, but it's not like one that you can do math with. It's just a category, right?
Yeah. We all agree on that one? The second and third one?
Mm-hmm.
Okay. Question number 3. The mean IQ scores in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores were 112. What is the following that is or are true? What do you guys think?
I think 100 is a statistic.
Which would make 112 a parameter.
Yes, that's what I think. What do you guys think?
Tess?
My
112.
computer says right now. I'm trying to figure it out.
Oh, shoot.
Gemma, what'd you say?
My computer internet is like going in and out, so it's hard to do, guys.
Oh.
Okay, so 112 is a parameter and 100 is a statistic? Is that what we decided on?
That's what I think.
That's what we're thinking. But we have two choices. Like, we can take the quiz twice.
True.
Mm-hmm.
Don't go wrong. On Nicole.
Oh, man.
Blame it
No
on
pressure.
Nicole.
Okay. Next question.
Okay, I'll read it. Question 4. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes?
Any thoughts?
What type of sampling do you think we should use?
Okay, random. Just really like it's being such pain. Okay.
Should we review what each sample is?
Mm-hmm.
Okay. So yeah, so random sampling is just like literally random. Everyone has a fair chance of being a subject
Mm-hmm.
selected.
Part of the quiz. Oh, yeah. Selected.
Mm-hmm.
And then cluster. Okay, I get this one mixed up with one of the other ones. But I think cluster is just where you put them into groups and then this is either the one where you select just one or two of the groups and ask them, or you choose people out of each group.
I think it's one where you choose out of each.
What was that?
I think clusters where you take the whole population of the group that you split it up into. So you split it, you take the cluster, you take the whole thing, and then you split them up, but then you just take the one group.
Wait,
Or
say it again.
Right?
Okay, I pulled up the definitions. Do you guys want me to read it?
I think it's the
Yes.
stratified sampling one.
What did you say?
I think it's the stratified sampling one.
Yeah, okay. So I have the definition. Let me just read it. A stratified sample divides data into similar groups, and a simple random sample is taken from each group.
Okay.
So that's the stratified sample.
Is that what we're feeling like?
I was confident with that one.
Let's do it.
Yeah.
Okay. 5. When designed experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grader students in that district. Then conducted using all of the students in the selected classes. What type of sampling scheme is implemented? Would that one be the cluster one? All items, not all items are.
I think so.
It's either that or stratified. But I think it's cluster, to be honest.
It's like for the cluster one, a sampling method of sampling all items in one or more randomly selected clusters. And they don't ask everyone. They didn't ask everyone in that one.
Right.
But they also didn't ask one, like someone from, they just like picked one school district rather than the one they picked more than one group to go from.
Right.
Yeah.
Oh wait, it says using, oh wait. I don't know if I jumped a question on when I was playing. It says all students from that class.
Yeah.
Yeah. Okay, I agree.
Sweet.
Keep talking me into it.
Whoa. Okay, I figured out how to do it on my computer. 1 second.
Look at you.
Sorry, I was like struggling trying to keep my phone balanced, so I just did it up real quick and was like, what?
Woo!
Good job. Proud of you.
Thank you.
Like you're in college or something.
I know. I learn new things every day. Okay, sorry, I'm back.
Okay, number 6. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented?
Random.
The simple random sampling. Good job, team.
Great. Question 7. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented?
It's stratified.
Yeah.
Question.
Okay, number 8. Okay, wait. A survey was taken to purchases at the crossroad. Open the data file and use this data to answer the next 3 questions.
Alright.
We're gonna need SSI, right?
Yep.
Or whatever
Yeah.
that is.
Has
PESS.
anyone been able to open it?
I could get it 1 second.
Yeah, does someone want to try and get it?
Mhm.
Do we all need to pull it up, or do we just want to have one person pull it up?
I don't know. I'm getting it up either way. Because I'm a very visual person.
I trust you, Nicole.
Oh no.
Oh, no.
Loading. It's such a slow software. It drives me crazy.
No joke.
That's why I'd rather just not mess with it because it's so slow.
I know.
I'm happy to only use it for one unit so far, one unit.
Yeah.
Uh-huh.
I really hope we never use it again.
Well, we paid $50 for it, so.
Yeah.
Did you say how often you're going to use it?
Mm-mm.
Okay, almost there. It's loading.
It's all right. Does anyone have anything else to do tonight?
Homework.
Homework, yep.
Homework.
Okay. All right.
Get up.
I believe so. Okay. Numero 8. There it is.
It says using software, calculate the mean of the amount spent.
Oh no. Okay. Sorry, my computer just did something really weird, and all the data just disappeared.
Ew.
Let me reopen it. 1 second. You can go ahead and eat. Go ahead and eat. No. This is so stupid. Every time I pull it up, there's no data on it anymore, even though it was just on there, but it like disappeared once I had it opened. So I closed it and reopened it, but it's nothing's popping up. Yeah.
Gosh dang it.
Okay, I got it back.
Yay!
I was gonna say I'm trying to get it right now, but my computer is running really slow. Find it yet?
So I have it. I just forgot how to find the mean on it. Because I don't remember how. Megan, do you remember how to find the mean on this? I think I wrote it down somewhere.
It's right here. You go to analyze, then you go to descriptive, explore,
Oh, I was right. Okay, and then what?
and then it's statistics, percentiles. You have to pick. Nicole, you got to pick that first.
I don't know what I'm doing now.
Well, you're choosing what you're trying to find, what they're going to find the mean for.
Did I choose the right one?
I don't know. What are you looking for?
The mean of the amount.
Yeah, you've picked the amount. Okay, and then the mean is right there.
I figured it out.
And standard deviation, and the median.
Thank you.
If you scroll further down, there's your percentiles.
Oh, thank you.
It might be those.
Okay. Thanks, Megan. Okay, so the mean is 4.7711.
Sweet.
Okay, so 4.771.
Yes. Yes.
What's the standard deviation?
Standard deviation is 1.912 if you're rounding it.
Yeah, just around 3 decimal points.
Okay, so 1.912.
Okay,
A histogram of it now. Great.
we have to make a histogram of it.
Of the same data that, is it the, wait, start by creating a histogram of the amounts. Yeah, okay. Explore, amount, plots, histogram. Continue. Okay. Okay, what's it asking for now?
It just says, did we create a histogram representing the amounts spent in the Crossroads purchases?
Yes.
So if we put true, and then we got it.
See. Okay. Jessica Mayer and her research team measured the body temperatures for a sample of diving elephant seals. Oh, that makes so much more sense. I just read it as elephants. A thermistor was placed at the specific location on each seal to measure its body temperature. The body temperature of the seals tend to decrease as they dive. The researches estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal. Thermistors were placed in the hepatic sinus of 4 of the seals. The seal's body temperature at the start of the dive was calculated to be table. Complete the following table and use your work to answer the next 4 questions. Okay.
Okay, so for Z, we have to find the mean. What'd you guys get for the mean?
38.075.
I got the same thing.
Okay, so for A, we take the mean and minus it from the 37.98.
Wait. Yeah, okay. I see what you're saying. Yeah, okay. Sorry, I was slightly confused, but I figured it out.
Yeah. So what'd y'all get? I got 0.
Negative 165.
Yeah, I got negative 0.165.
Perfect.
Okay, so now find the B.
So for the n square.
we subtract the mean from the seal temperature, or do we do it the other way around?
Yeah, the seal
For-
temperature minus the mean. Right?
For A or B? Which are you talking about?
For either one of them. I don't know. That's what I was asking.
Yeah, I'm pretty
Is that-
sure it's that you're taking the mean away from whatever the number is.
Yeah, x with the line above it equal is the like symbol for the mean.
You're right. You guys are right. Making me feel like an idiot.
No. It's better to ask.
Just kidding. What'd y'all get?
Six, eight, one.
Yep.
Yeah, that's
So I
what I got.
Beautiful.
Sweet.
Number 13. What quantity is equal to the sum of the numbers in the standard deviations column?
Wait, time out.
Mean, standard deviation, the variance.
What did you guys say for 12 again?
It's 0.681.
0 point what?
681.
Oh, yeah, okay, yeah. Sorry, keep going.
You're good.
All right, so number 13 is what is the quantity equal to the sum of the numbers in the square deviations column? I think it's the variance.
Yeah, I think you're right.
Yeah.
All right.
Okay. Question 14. What is the standard deviation of these temperatures? What'd y'all get?
Okay. I got 0.7700919859.
I'm still working on mine right now.
Yeah, I've almost got it.
Aha.
What'd you get?
I got rounded to the third decimal would be 0.770. What you get?
Not that.
Mine might be totally
What did you
wrong.
I got 0.0296.
Oh man, I got 0.5.
Dang it!
My time.
How did you guys find the standard deviation?
I figured out what all of column B was and then added them all together and then found the variance of that and then found the standard deviation from there.
Okay.
What did you do?
Sorry, I'm trying to figure out if I did this right or wrong.
Okay.
Yeah, so I found out all of column B, and then I did the square root of that number.
Okay, so you have to take the sum and then divide it by the sample size. So this was 4, and then subtract that by 1. So it's the sum divided by sample size minus 1 underneath, and then you find the square root of that one.
Okay, so I skipped a step.
Yeah.
Did you redo it, Gemma?
0.715. 0.715.
I got 0.770. Dang it.
Oh, I don't know.
I don't know what I'm in the wrong here. Because I know the process, I may have just gotten the numbers wrong.
Okay, well, tell me the process. Walk me through the process so I can make sure I'm doing it right.
Okay, so you got your table filled out?
Yeah, so I have all of B filled out.
Okay, so you found the sum of B?
Yep.
Okay, so then you just take your sum and put it over, and then down the bottom in parentheses would be 4, because there's 4 fields, minus 1, and then that's your variance, and then you just square root the variance to get your standard deviation.
So are you taking the whole column of B or just the letter B?
Oh, sorry, yeah, the whole column of B. Sorry, that whole column.
So you're adding all of column B up, you're dividing it by 4, and then minusing it by 1, and then square rooting that.
Dividing it by 4 minus 1.
Yeah.
Yeah, sorry, just make sure it's all together. Or you can plug it into SPSS and figure it out on that. But I try to avoid that program.
Every time I put in my calculator, it says it's error, so I must not be doing it right.
Okay, 1 sec. I'm trying it on Excel now.
Anything, Gemma?
I'm redoing the whole thing to make sure I did it right.
Yeah, me too.
I just love math. It's my favorite.
Is this everybody's last math class for their major?
Yes.
I believe so.
Yeah. It's the only math class I have to take.
Yeah.
Well, then better freaking pass it. Okay, explain to me why you're minusing the 1.
Because that's what was just in the equation that I have written down. Here, I'll show you. I take notes of the, like, what's in the book and in the videos and stuff.
Yeah.
And so, does that help, or is it all backwards?
So,
It should be right here. So you define your variance. Here, it's sum over n minus 1. And then here I have an example here. And the sum is 40. And then you did 40 over 5 minus 1 was 10, and then found the square root of 10.
okay. Why doesn't you move? Okay. You want to come do it right now? Okay. I'm coming. Okay. Well, I'm going to step away just for a second because
Okay.
my fiance wants a blessing. So keep working on that math problem.
Oh.
So what did you guys get?
Wait, I think I found an error I did. I like missed a 0 somewhere.
I got 0.715 again.
That's probably right. 1 second. Okay, I got 0.715.
Oh,
That's what
geez.
you got, right?
Yeah.
Okay, sweet. What I did, I just missed a 0 after the decimal
Yep.
place on the top one. So.
Well, I got something different, but I'm sure you guys both got something.
What did you do, Tess?
What did you get?
I got 0.619. So, I bet if both of you guys got the same one, then it's probably correct. I'm figuring out again right now.
All right.
Oh, you guys got 0.715?
Yeah.
Yes.
Ah, I got that too.
Perfect.
Hey.
Awesome. Okay, should we move on and then come back or re-explain everything to Alex?
Yeah.
Okay.
Yeah, that works, especially if we have to do another one that took so long because that
I
one
know.
goes on.
Okay, question 15. Under certain conditions, the standard deviation can be negative. True or false?
False.
Okay.
Where's the other one?
Right. Okay, in the same study, the researchers placed thermistors on the 3 seals near their spinal cord and brain in the extral vein. They placed thermistors in 6 other seals in their aorta and largest artery in the body, or the largest artery in the body. Finally, they placed I can't say that word, in 4 other seals in their hepatic sinus. The results from the study are summarized in the table below. Question 16. Which location resulted in the most consistent temperature measurement from one seal to another?
The extradural. That's the smallest standard deviation.
Yes. Wait. Yeah.
Well, they have different numbers of like sizes, so I don't know if that affects it.
Oh, yeah.
We have to do like the weird standard deviation equation with the
What's the equation we use for that?
It's like the normal standard deviation divided by the square root of the number. Okay, let's do these.
Okay. Okay. For me, I still got extra roll is still the smallest.
Perfect.
Yeah, I got the same. That's nice.
Okay.
Beautiful. I just don't want it to like trick us up.
Yeah, better safe than sorry.
Mm-hmm.
Okay.
Number of hours students spent studying on an exam were recorded. The data are represented by the box plot below. Use the box plot to answer the next 2 questions.
What is the
What
third
is
quartile?
the third?
6? No, 8. Sorry, that's 8.
I was like, wait, 6.
Sorry, I thought it said 6.
Well, yeah, I thought the same thing too, actually. So that's good.
It's so little. The one on the back? That's fine.
Oh yeah. What percentage of the data lies between 4 hours and 8 hours? No, list the number as a percent and not a decimal, and don't include the percent sign.
Okay, between.
Okay, team, I'm back.
Hello.
Hey.
What question are we on?
18.
What?
Yeah, we're good. We're cruising. Want us to go back and talk it out?
Yeah. What did you guys decide as the deviation?
0.715.
What is it?
715.
Okay. I believe you. So
And then
15.
we said 15 was false, but the standard
Okay.
deviation.
16.
Extra roll.
Because the standard
Okay, and
deviation is
17.
the smallest.
And then what was 17?
8.
8.
8. You just read 18, right?
Mm-hmm.
Yes.
Okay, let's do it.
Okay. Can someone talk me through this one? Because I don't remember what to do.
I'm trying to remember what like lines are demonstrated in the box plot. It's the 5 number, right?
Find the percent.
So the first quartile is at 25, so number 4 is 25%, number 6 is 50%, and then 8 is 75%. So would it be 50% within that because 75 minus the 25?
Wait 1 second, I got it right.
So 4 is 25%, 6 is 50%, and 8 is 75%.
So it would be 50% because
So
Yeah.
4 and 8 would be 50%.
okay.
Go team. Okay. Do we agree? 50%? We're good?
Yep.
Yes.
Okay. So the next one, 19. Use the following information to answer the next 3 questions. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm, which is parts per million, are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 ppms, and values outside of its range are unusual. We will assume that the mean minus 2.0 equals 1.59 ppm, and the mean minus 2.0 equals 2.52 ppm. It is reasonable to assume the measured nitrate concentration is normally distributed. Go. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water. Okay, so we need to find the mean.
Mm-hmm.
What would our first step be here?
I don't know.
Okay, wait. So we know that the mean should be somewhere between 1.59 and 2.52.
And 2.52.
Mm-hmm.
Okay.
I feel like this is not like any other question we've answered before.
I know.
The thing is, I don't even know where to begin. And it says estimate it, so it's not like we're looking for one specific answer.
If we can't figure out how to do this one, we can't figure out how to do the next three. Or two more after that.
We just add those two numbers together and divide it by 2.
Well,
We need to figure out what the standard deviation is in order to be able to solve for the mean.
so there are 4 standard deviations away from each other. Could we like, I don't know.
Can we put it in the, what do you call it? The normal probability applet? Can you put it in there? Will that give us the mean?
I don't think so, just because we wouldn't be able, for the normal probability applet, the two z-scores are like at the same, it's equal on both sides, and we wouldn't be able to plug in 2 separate, like a different high and a different low. You know what I'm saying?
Yeah. I wish it would tell us like what lesson this is all from, so we'll go back and look at it.
It might be actually giving us, okay, so the equation for the z-score is z equals x minus the mean divided by O.
Right.
X. So if we move the u over, we are subtracting it, right? So like if our equation,
What's x?
X is the
1.9 or
1.5.
2.52.
Oh, okay.
So you would minus the mean to the other side, and you'd have a negative 2o minus or equals 1.59 minus the mean.
So then we do so then we just divide it to, I don't know how to find it. Okay.
What does the represent?
I think our standard deviation is 2. Wait, just kidding. Our z-score, I think our z-score is 2. So that's like plus and minus 2. Because if you subtract the u, which is the mean from 1.59 or 2.52, and then divide by the sigma sign, whatever it is, that equals the standard deviation, you just have either the 2 or the negative 2 left. So those would be your z-scores, right?
A negative 2 and a positive 2. That leaves you O equals 1.59 minus the mean divided by the -2, or vice versa for the other one.
Yeah. Wait.
Do we know what the 0 represents in the equation?
That's the sign for,
Standard
but I don't know how to find it.
We don't know the standard deviation.
Yeah, we don't know the mean or the standard deviation.
Oh. Deviation. Just a second. These cards.
Well, this sucks.
Okay.
Megan.
Yeah.
Is on the one that is where it tells you that the mean minus 2 standard deviation equals
Megan, we need your brilliant mind.
yeah. Eight.
Values. Oh, what if we equal the equations to each other?
So you do the mean plus 2, 0 equals 2.52 equals the mean minus 2, 0 equals
So
1.59?
2 is going to equal the same both ways, right?
Yeah.
Or the mean is going to be equal to the same. So we just saw, just a second, let me go back to where equal the same. So we want to do 1.59 plus 2 times like the standard deviation equals 2.25 to the standard deviation, and we'd have this because there's there's a u in each equation, right?
Mm-hmm.
We could solve for the standard deviation, and then we can do the opposite. I don't know how to solve, and then we can plug in the standard deviation to figure out the mean. Maybe I'm gonna try it really fast.
Holy cow.
So you're saying if we put the two equations next to each other, the plus 2 and the minus 2 cancel each other out?
No. So what I did is I solved for u in each equation.
Yep.
So the mean is going to be the same in both, right? So I'm going to put u equals 1.59 plus 2. U equals 2.52 minus
Okay.
2 sigma. And then I'm going to put those equations equal to each other.
Okay.
5 plus 2 equals 2.25 minus 2 times the standard deviation. Then I'm going to solve for the standard deviation.
Okay.
So I'm going to add the 2 standard deviation from the one that's subtracted. And then I'm going to subtract the 1.59 from the 2.25.
Yep.
And then I'm going to divide by 4.
Okay.
And then we'll have the standard deviation, and then we can plug the standard deviation in to figure out what the mean is.
So what'd you get for the standard deviation?
calculator real quick. Minus 1.59 for 0.165.
Catch you awfully quiet.
This is blowing my mind.
I don't know. Hopefully this is accurate. Okay, so then I can plug in.
So
If I
now-
can get if the mean equals the same thing in both equations, then we know that we did the standard deviation correctly. So I'm going to just plug it in real quick.
Alright, give it a shot.
Okay, so 1.594 times 1.93 and minus 2
Yeah. Well, looks like it's just you and me, Tess.
I know.
I'm still here.
Oh, hi, Nicole.
Oh, hello.
Where did Gemma just like peace out? Like I'm done with this?
She's done.
She probably got too stressed out by the question.
I
Honestly.
agree.
Wait, I got my most brilliant minds on it right now. And by that I mean my sister who's taking this class on campus, and so they're like a lesson or two ahead.
Ooh.
That is Megan your sister?
Yeah, we're roommates also.
Megan! We need your help.
Honestly.
Is she older or younger than you?
She's 2 years older than me.
Oh, how cute.
So,
What
yeah,
are you
she
guys-
put off having to do her math class till like her last 2 semesters.
Oh.
So
This is the worst.
Mm-hmm.
I figured if I can just do the math right away, then I won't have to worry about it.
Sure why you do it that way. That's fine. I know how to do it. We need you. Okay.
If I was there, I would cook dinner for you, Megan, and you could help us out.
Hello, class. Hello. Okay, so what you're gonna do is you have to take these two values right here, and you're gonna subtract them, and that'll give you 0.93. And so, hold on. Okay, so you go 2.52 minus.
Wait, you messed up.
Oh, 2.52 minus 1.59. That'll give you 0.93. And
And then
say,
you don't remember why to do this?
no, well, I know why you do that. And then you divide this by 2. And that'll give you this answer here, the 4.65.
And that's the standard.
No. The standard deviation, you would divide this one more time by 2. That's your standard deviation.
No.
Okay. See, I don't
No.
know why, but that's the answer. That's how you get the answer. But I don't know why you get it that way.
What if you're wrong, Megan?
I'm not, because I already did this one. I already checked the answers.
Trust me, I'm not wrong, okay?
Well, when it comes to math, my group helped me with this one.
And then we just.
Mhm.
Did you guys get that, or do you want me to relay it to you?
Are you talking to us?
What'd you say?
I said, did you guys get what she said, or do you need me to relay it to you?
Well, she took the 2.52 and minused it from the 1.59 and
Okay,
then by 2 and then divided it again by 2?
Yeah, and that was the standard deviation. And then, once you divide it again by 2. Yeah, that's what he said. Sorry, I plugged in my headphones. So you didn't hear it. Yeah, and then that's the standard deviation. Then you plug that into the equation to find the mean. Wait.
So wait, what did she get for the standard deviation?
0.2325.
Okay, sweet. Okay, that's what I got.
But we're only rounding at 3 decimal places, so it'll be 0.233. So then we plug that into the equation, and that will give us the mean.
Yes.